Okay, let's get into this. We're doing a deep dive today on a really interesting piece of tech. It's a solution that seems designed to just completely smash the distance limits on old school video and audio signals.
It really is.
Yeah,
And the core problem is, well, it's just physics.
right.
If you, as the listener, have to send a standard analog video signal, we're talking composite or CVBS, over a traditional copper cable, you just hit a wall,
A hard wall.
very hard wall. After about 100 feet, the signal just degrades. It becomes completely unusable. For any large campus or industrial site, that's a huge crisis.
So the solution is to get off copper entirely. You jump the signal onto fiber optics, turn it into light.
Exactly. And this kit we're looking at, the Thor F-8V16A-TxRx, is a transmitter and receiver pair that does just that.
And it does it at scale. We're looking at sources that say it moves 8 video channels, 16 audio channels, and even data.
And that's the RS-485 serial data, which is key. All of that goes across a single strand of fiber. Could be single mode, could be multi-mode.
Okay, so we're getting past that 100-foot copper problem. But by how much?
Well, this is where it gets kind of wild.
Uh,
The standard units, right out of the box, they push the signal up to 20 kilometers on single mode fiber.
20 kilometers, just the standard model.
That's just the baseline. But if you have, say, a really huge long-haul need, there are versions that can do point-to-point up to 120 kilometers.
120, that's an astonishing range for what started as a simple analog signal.
It is.
Doesn't that just completely change the game? You don't need all those expensive little repeaters dotted across a huge network.
You've got it. It totally changes the total cost of ownership. For a university, a military base, pipeline monitoring, you name it. It simplifies the whole architecture down to one point-to-point link.
So we've solved distance. But what about quality? Are we losing anything in the translation to light and back? I mean, this is meant for legacy sources, right? VCRs, old set-top boxes.
It has to be. A lot of specialized security and industrial systems still rely on the simplicity of analog. So yeah, it supports NTSC, PAL, CCAM, all the standards.
And the connectors are the tell, right? It's still using BNC 75 ohm.
That's the one. And that 75 ohm impedance is so critical. It minimizes reflections, keeps the signal clean, and it's why it's still the standard in these high reliability fields.
Okay, so the input is analog, but the encoding must be digital and broadcast quality, from what I'm reading.
Oh, absolutely. The video is handled with 10-bit digital encoding.
And that 10-bit depth is a big deal.
It's huge. Compared to older 8-bit systems, you're capturing so much more color information, more detail. The video stays sharp, running at 10 megahertz bandwidth.
What about the audio?
Just as solid, 24-bit digitized audio. The signal-to-noise ratio is better than 79 or 80 dB. It covers the whole human hearing range, 20 hertz to 20 kilohertz.
And you get 2 audio channels for every video channel, so stereo is just standard.
Left and right, yep, standard.
Let's talk about that control aspect, the data. It's not enough to just send the picture. You have to be able to control the camera on the other end.
And that's where that RS-485 interface earns its keep, a vital control link.
Running it, what was it?
Up to 115.2 kbps. More than enough to send commands to a PTZ camera 50 kilometers away and tell it to pan, tilt, or zoom, or pull data from a sensor, all in the same fiber.
The sources also mentioned something really specific. It's used for high-level timing applications, sending a CVBS blackburst or sync pulses over fiber. Why is that so important?
Well, think about a modern broadcast studio. Even if you're pulling in one analog feed, you need to sync it perfectly with all your other digital cameras.
To avoid glitches.
Exactly. And that requires a modern timing standard, which is called tri-level sync.
Yeah.
The fact this unit can carry that pulse reliably means you can integrate legacy gear into a complex digital setup without any latency or timing issues.
So when we boil it all down for you, the listener, what we have here is this incredibly powerful tool. It future-proofs high-quality analog systems.
It ensures that distance is no longer the enemy, and that you can maintain precise control and timing even over those huge distances.
The big takeaway really seems to be that you can stick with these proven, robust analog signal types, like BNC 75 ohm, without being stuck on that 100-foot leash.
That's it. Which brings us to the final thought. If a modern fiber link can extend the useful life of an analog system by 120 kilometers, what critical non-IP systems are you still relying on today? Things in security or command or industry that absolutely need this kind of extreme reliable reach?